I've figured some stuff out. Oh, have I not been wearing these headphones the whole time? Because it sounds different now. Okay. So I've figured some stuff out. So looking at my screen here, we're subtracting this one, right? Because um, right, the range does not include the last, I guess, slot, if you want to call it, and that's why I was subtracting one, but we know it's not quite subtracting one, it's like subtracting like some type of scaled pixel value. And I said it was either that this value is either equal to the source viewport divided by the destination, or the destination divided by the source. So I did some calculations on some graph paper, then I moved them over to a nice little ASCII diagram here to try to figure out what that was. So I'm kind of simplifying the problem and saying that if our source data is like a 2x2 bitmap, and this pixel represents data for a tile, this is data for a tile, this is data for a tile, and this is data for a tile. For example, this could be a red pixel, and maybe if the pixel is red, it maps to I don't know, iron ore tile set, right? And then maybe this is like a green pixel, and that maps to a grass tile set, right? So this is like a pixel, and its value is, so it's RGB, right? So maybe it's 0, 255, 0, right? And so the green channel is all the way up, and we're just going to interpret a mostly green pixel as mapping to a grass tile set. Obviously, we're wasting a lot of bits if we do that, but I'm just trying to simplify the problem here. So anyways, we got our 4x4 tile map, which is stored as a bitmap off screen in the source viewport, or the source viewport is looking over this, and we're saying that the source viewport right now is just perfectly snapped to this data set. Then we're going to say that our destination viewport, we're going to say that's 1, 2, 3, 4, 5, right? And I'm purposely using something that this does not evenly go into, so we can mess with fractional values. So to map this onto this, we kind of have to stretch this until it overlays over this. So this first tile is going to take up 2.5 pixels on the X and Y axis, and then this next tile here, right, there are all tiles are of uniform size, so this next tile will also take up 2.5 pixels on the X axis as displayed on the destination viewport. So now that we have that out of the way, we can think about the problem in terms of like these fractional pixels that are a little bit smaller than an actual pixel. So if we go down here, I've tried to like split the partition the destination viewport into which pixels belong to which tile. And you notice these two full pixels belong to the first tile, but then this pixel in the middle right here, half of it belongs to the first tile, and then half of it belongs to the second tile on this map here. So we need some type of unit that's not quite a pixel. So I'm just going to call this unit, I'm sure there's a better conceptualization of this, maybe calling it a fragment. I'm not quite sure. I don't know. But I'm just going to call it a scaled pixel. And so there, in terms of scaled pixels, I guess you could say that there's like maybe like 1, 2, 3, 4, 5 scaled pixels in here. I think that's kind of how I want to conceptualize that. Does that make sense? Because if there's 5, and then I have this calculation here, 5 times 0.4, what would that be? So let's open up a calculator here and see if that is sensible. So 5 times 0.4, that gives us a 2. 5 times 0.4, that gives us a 2, and what does that conceptually mean? Yeah, I'm not quite sure what the hell that means. And why the fuck did that use Bing? Didn't I tell Firefox to use Google? Okay, I'll worry about that later. So going back here, So that gave us a 2, but it didn't give us a 2.5, right? Because this is a 2.5. That 2 might be kind of correct, because the idea is, right, when we have, if we had a, if our tile was exactly 3 pixels wide, then the values for coordinates would be 0, 1, and 2, but it would not include 3. So if we're like taking all the possible positions that can be here, the last position should be less than 2.5, I believe, yeah? I don't know, my logic is still kind of fuzzy here. Like, I'm definitely missing something. I definitely don't completely understand this problem, but what I do either understand or have a pretty damn good hunch is that this calculation here, right, which gives us a fraction, that should be the value, this scaled pixel, viewport 0, so the scaled pixel of the destination, right, is 0.4, and that should be the value right here. So instead of subtracting 1, I think we should be subtracting 0.4 in this case. Now, I could be wrong about this, but I have a pretty good hunch that that's what needs to be done. So we'll take this diagram that we got right here, and I don't know if we're going to take all of this. I have this for reference for myself for later, but I've been packing way too many. I mean, we could do that. We could like comment this up a little bit more, right? And we could make this into some completely valid code, and we could just throw that in there. I mean, but look at how much space this takes up, and we're already like taking up a lot of space. You know, we could like go right in here, and we could like have a scaled pixel value, SP. And then we could just do like SP scaled pixels, pixel value, whatever, and then below, and then we'll just like we could make that really it would be like that, and then we could do that, and we could. I'm just trying to make this area a little bit thicker because the longer the section of code is, the more I want to like make the boundary a little bit more obnoxious, just so that the divider line is kind of like proportional to how long the code segment is, so it's harder to miss it if I'm trying to scroll up and down through it. But yeah, I guess, you know, maybe we'll just take this. Oh boy, but it's probably not properly indented because we're nested pretty deep. Like how deep we're nested. Okay, we're only nested 2 deep this time, so we might be able to like shuffle this around and fit it. Yeah, because we're already. I don't know, man. So we would have to go like. Well, it's not everything because this is going to be. Okay, well, let's get everything indented deep enough. And then let's trim down some stuff. So let's just trim this down a bit. And we'll do the same thing over here. We'll trim this down. And we'll trim this down. And okay, so we've trimmed that down. And now this isn't completely centered, but I'll try not to let that bother me. Do we want to... Well, if we just compress this a little bit, right? If we compress that a little bit, we're within our... we don't go off the screen. Okay, yeah, so we can do that. And these are just our examples, our little examples to like get an idea. And then we can do over here, we can just... I think we have enough room to just write it like this. And why is that? Okay, so I just wrapped this in comments, and then we can put a nice little border around that. Alright. And then same thing with, we got a diagram up here. I want to do the same thing and kind of like get this ready to like throw this into our source code. Even though this is kind of like this is an obnoxiously large comment, but you know, picture's worth 1,000 words, you know, so I think it'll be helpful. Definitely, because of how long this function is getting, definitely we would want to like offboard this function probably to its own file and reference it, because I think we've written it generically enough that it's kind of like a procedure that we could reuse. Okay, so we got that. And do we want to keep... Sure, why not? Let's just keep it all. And we can just kind of do that. Take the top here, kind of close that off as well visually. Okay, so all these notes. Now the problem of making so many notes like this, the downside is, you know, when you read through the code, it's going to be like, and then this big, huge rant about all this blah, blah, blah stuff before it gets, you know, back into the flow of the code. That's kind of like the disadvantage of what we have here. Also, we are using these values, so those values exist in the source, and do they exist at the point at which we want to put them in. So we're going to go Control-Shift. Well, no, let's just, we'll put breakpoints there. And then we're going to look for, so we're about at 530. And where are these defined? Are these defined before 530? Yeah, we got this before 530. But do we have the VP0 width? Is that defined before 530? Yeah, so this is defined up here, and this is defined down here. So that's, yeah, so that's actually right about, we've kind of like inserted this right about where it's needed, like in our, right, there's some flexibility in the order in which we can put statements, but this seems like a pretty logical place to be because the variables we need have just been defined. So yeah, we can just throw that in there in that spot and we'll be good. So we're going to take all of this. Let's make sure this is correct though first. Let's do a little check here. So let's use a color here for the width, and then we'll use another color for the height, and we'll say, oh, yep, that looks about right. And then let's use another color for VP1, and then we'll use another color for VP0. And we notice that it's flip-flopped right here, and then it's flip-flopped here between that purple color and that off yellow color. And right, the width is on the top, height is on the bottom, width is on the top, height is on the bottom. So everything looks correct here. It doesn't look like we made any transposition errors. So we'll remove the coloring there, and we're just gonna, oh, you know what? Before we throw this in, I have a little note of what this diagram is, and so I'm just gonna say. So for my own personal reference, I just want to know that this is where I can find this original diagram. If I want to find this original diagram, I can find it, you know, here. And then also usually I have like a, when I'm doing this, right monitor, I can just make a note. So here's the shortcut for that diagram. And maybe we need, we can make like a shortcut that's more of a hard-coded constant that'll never change, like a perma shortcut or a permalink, math tile SP diagram. And then we'll take that perma shortcut that's kind of more hard-coded, and we'll just say right here, oh, hold on, let me go over. Okay, so and then over here what we can do is you can just take this and that way I have two ways of getting to the information. So if for some reason something happens to this shortcut, I can always fall back on this file path, but this is going to be like the fastest way to get to it because it's right at my fingertips. But I have two ways to get to it, or maybe like I refactor and shuffle things around, so maybe like both of these become invalid because this file is in a different folder, but I can still kind of like at least search for this file name. So just enough traces so that if I want to hunt down where I initially drew up this diagram, I can find it. Because maybe I want to write some code similar to this again in a different language or in another project, and I'm doing it from scratch again, and I just want to be able to reference these notes to get an idea of what I'm doing, right? Because sometimes I'll have these notes on one monitor while I'm writing code on another monitor, right? So you have your nice diagrams on one monitor, or your reference or your documentation on the other monitor while you're like writing the code. So that looks good to me. Let's just take that, and now we're gonna paste it into this monster of a file we have. Okay, and then if we double click that, we can see where the section of all of this starts and ends. And the next part is we can close this. Like we don't need more things open than necessary. And even all these thoughts here that we had a while ago, kind of the scratch pad that we started with, where we're trying to figure out some of the logic for the problem, we can probably close this now too, as well as that page. Now we just got one thing open. Okay, so the moment of truth is really quick glancing at this cluster of variables and this cluster of variables. Without really comprehending it, I can just grab this 0.4 and I realize that, oh, this is the one where the pixel is smaller than one fraction, and this one is not. So this must be the size of the pixel as it appears on the destination viewport, and that is what this is, because this is SP0, so scaled pixel 0, and the width and the height. So we'll take this, we'll grab onto that, and we still looks like we have the breakpoints for where we were making these calculations before, and we're gonna just take this and this, right? The width and the height. And then, so this is, since we're running out of room here, we can put this here like that. And sometimes I will, x0 and then, or y0. Slash min, because that's what it represents. And or we could write it like this: min, and then it's x0, y0. Yeah, we could write it like that. It's doesn't. All it has to be is I'm just writing kind of a shorthand notation of what this down here represents. So tile internal coordinate, and it is the min value, which is represented by a x0 or a y0, and that's totally wrong because this is the max. So yeah, sometimes, like I said, your comments can be wrong instead of your code, right? It could go either way. I like the redundancy though, because once these two things agree with each other, right? To me, I think if the comment is wrong or if the code is wrong, then it's wrong. Then you have a problem. Fix both of them, maintain both of them. Okay, so these are the mins, these are the maxes, and I could make a little note. Okay, so if if rec VP1 can be overlaid completely evenly into rec VP0, then SP0 width and SP0, gonna have to stop recording soon. So then SP0 underscore width or height is going to equal, they're both going to equal 1. Or we could do this, 1 and 1, and then, I don't know, we're not going to worry too much about that. Okay, so with that assumption, which that should definitely be correct, so maybe we should add some error checking code that when the two viewports do map onto each other to where everything goes into each other evenly, that we check and make absolutely sure that these are now both 1, because that's kind of the assumption we're working with. And we should test that assumption, because if that assumption is not correct, then if that assumption ends up not being correct, then as much as I would, like to be done with this and be correct and be right, well, I'm not right, because there's still some flaw in my logic. So now this error is not going to be tripped while we're currently running, so we might run into it later, right? Because right now the source viewport and the destination viewport do not go into each other evenly. But let's say if they did, so like we're not inside of the loop yet. So let's say so if and it's the widths of the viewports, right? So I believe we calculated those. Okay, so we will take the larger viewport. So VP0, right, the destination viewport, and the width of it divided by the source viewport. And if that if this equals itself floored, so if this equals math.floor, same thing, then it goes in evenly. We could make a function for that, right? Because it's obviously sometimes I don't like writing functions for things I'm going to reuse anyways, just because that leads to like more indirection and searching around the code for where something's defined. So we could just do math.floor, right? And that means that if these two are equivalent, it means that there's no remainder. Is there another way to do that? I don't think there is. So we can actually error check on both axes. Even though we are using, we all have decided that our tiles are always going to be square. But there could be a case where our viewport is slightly stretched or something on one axis, and so one of these cases is true and the other is not. So the bigger viewport, right, and then the smaller data set, I mean, that's not always going to be the case, but, okay. So in the case that, so I guess that is the other assumption. The assumption is that the destination viewport is larger, right? So if we have 512 by 512, are larger or the same size, right? Yeah, maybe this is not correct. They go in evenly. No, I mean, as long as it goes in evenly. I don't think it matters which is larger and which is smaller. Okay, I could be wrong, you know what? But it doesn't matter if I'm wrong or not with this assumption, because if the error eventually happens, then I can just take the time to figure out, is this actually an error, or do I have an improper assumption, right? And it'll help me kind of like figure out, it'll help me understand the problem a little bit more. So math stuff. Okay, so if they are equal, right, if they go into each other evenly, then I'm just expecting that this calculation here will be equal to 1, right? So if not equal to 1, or yeah, not equal to 1, right? Because this is the width. And then throw sp0 width not equal to 1, right? And then we'll do the same thing, but we're going to do it with the height. And actually, let's put up. Okay, and then this would be the width, but now this is the height. Okay. And maybe a little comment that I'm pretty sure this is true, but not 100% on this. Not 100% sure this is this assumption is true. So error being thrown might not be indicative of a problem, but re-evaluate your conceptualization of problem if drift. Okay. So just a little note. So if this is just a note so that when I find this error gets thrown, I don't try to like change the logic so these conditions don't happen. I don't immediately say that's the fix. I can say that might be the fix, or maybe you don't quite understand the problem. Maybe you gotta reevaluate it. Anyways, I need to record another video.